Single covalent
Chapter
bonds
6,
are formed.
Section 2. After this video, I hope that you can explain how to determine Lewis structures for molecules containing single bonds, multiple bonds, or both.
Formed when one pair of electrons is shared between two atoms, as shown in this molecule made up of two atoms of fluorine.
Lewis structures. Electron dot notation, as we saw in the last video, can also be used to represent molecules. For example, a hydrogen molecule, H2, is represented by combining the notations of two individual hydrogen atoms, as is seen on the screen now. The pair of dots represents the shared electron pair of the hydrogen-hydrogen covalent bond. For a molecule of fluorine, F2, the electron dot notations of two fluorine atoms are simply combined. Here, also the pair of dots between the two symbols represents the shared pair of a covalent bond. In addition, each fluorine atom is surrounded by three pairs of electrons that are not shared in bonds. An unshared pair, also called a lone pair, is a pair of electrons that is not involved in bonding and that belongs exclusively to one atom. The pair of dots representing a shared pair of electrons in a covalent bond is often replaced by a long dash. According to this convention, hydrogen and fluorine molecules are represented as follows on the screen now. These representations
The dots
are all
represent
Lewis
electrons.
structures, formulas
The shared
in which
electrons
atomic
can be
symbols
represented
represent
with a
nuclei
line.
and inner shell electrons. Dot pairs or dashes between two atomic symbols represent electron pairs in covalent bonds, and dots adjacent to only one atomic symbol represent unshared electrons. It is common to write Lewis structures that show only the electrons that are shared, using dashes to represent the bonds. The structural formula indicates the kind, number, arrangement, and bonds, but not the unshared pairs of the atoms in the molecule. For example, F2, the fluorine to fluorine bond, and HCl, the H to chlorine bond, are both structural formulas. The Lewis structures, and therefore the structural formulas, for many molecules can be drawn if one knows the composition of the molecule and which atoms are bonded to each other. Sample problem 6.3 on page 171 of your text illustrates the basic steps for writing Lewis structures. Please refer to the basic steps on writing Lewis structures from the last video. The molecule described in that sample problem contains bonds with single shared electron pairs. A single covalent bond, or a single bond, is a covalent bond produced by sharing one pair of electrons.
This is often simplified to a single dash, representing
multiple covalent bonds. Atoms of some elements, especially carbon, nitrogen, and oxygen, can share more than one electron pair. A double covalent bond, or simply a double bond, is a covalent bond produced by the sharing of two pairs of electrons between two atoms. A double bond is shown by either a two side-by-side pairs of dots or by two parallel dashes.
representing a single bond between the symbols for the elements involved. Double covalent bonds are formed when two pairs of electrons are shared between two atoms. Again, each set of shared electrons can be represented with a line. Double covalent bonds are usually shorter and have higher bond energies than single bonds. Triple covalent bonds are formed when three pairs of electrons are shared between two atoms. Each set of shared electrons can be represented with a line. Triple bonds are usually shorter and have higher bond energies than single or double bonds.
Before we move on to resonance structures, please remember that in writing Lewis structures for molecules that contain carbon, nitrogen, or oxygen, one must remember that multiple bonds between pairs of these atoms are possible. A hydrogen atom, on the other hand, has only one electron and therefore always forms a single covalent bond. The need for a multiple bond becomes obvious if there are not enough valence electrons to complete octets by adding unshared pairs. Resonance structures. Some molecules and ions cannot be represented adequately by a single Lewis structure. One such molecule is ozone, O3, which can be represented by either of the following Lewis structures. Note that each structure indicates that the ozone molecule has two types of oxygen-oxygen bonds, a single and a double. Chemists once speculated that ozone split its time existing as one of these two structures, constantly alternating or resonating from one to the other. Experiments, however, reveal that the oxygen-oxygen bonds in ozone are actually identical. Therefore, scientists now say that ozone has a single structure that is an average of these two structures shown on the screen now. Together, these structures are referred to as resonance structures or resonance hybrids. So, resonance refers to a bonding in molecules or ions that cannot be correctly represented by a single Lewis structure. To indicate resonance, a double-headed arrow is placed between a molecule's resonance structures.
Some molecules and ions cannot be adequately represented by a single Lewis structure. At one time, it was theorized that the bonds in molecules like ozone resonated or alternated between single and double bond states. Later investigation proved that the two bonds were actually identical. The resonating bonds never existed as pure double or single bonds, but as something in between, both with respect to bond length and strength. The electrons in these bonds were somehow shared evenly across the structure. Electrons shared in this way are said to be delocalized. Resonance is frequently represented by two Lewis structures joined by a double-headed arrow.
At this point, I hope that you can explain how to determine the Lewis structures for molecules containing single bonds, multiple bonds, or both, and explain why scientists use resonance structures to represent some molecules.